All right. Today's project actually required me cleaning off the desk because I picked myself up a laser engraver / cutter. So the instructions are pretty straightforward. If you're wondering why I'm getting this when I have the CNC router, it's kind of like using Thor's hammer on a piece of paper. Like you're firing up a 2 horsepower router, you need to wear ear protections, and you're basically cutting out a small piece of paper. It's ridiculous. It's loud, it's great for cutting out wood and stuff, but when it comes to little things, it's just a nightmare. The workpiece hold down too. When you're cutting something that small, not fun. This nice, small, compact unit should fit nicely right here on my desk. Should be able to use, because you can go on the internet and download files and stuff and just make things that other people have already designed. With my machine, it takes a little bit of tinkering to do that. So I guess in the world of the maker space, I guess you would say, this is a much better option for me. So here's our gantry. We have a little servo motor, little connectors, ball bearings, roll really good, no backlash. Power cord, we'll worry about that later. Some extruded pieces here make up our overall frame. Bag of hardware, a little computery brain unit, USB cable, paintbrush, don't know why that's in there, and some tools. So it looks like they kind of give you everything you might need. So let's put it together. I mean, this is really funny. So we have step 1. We have no step 2, which at first glance you think, oh, I'm missing parts. No, step 2, you're assembling the gantry or installing the gantry. It's not until step 3 where you start needing stuff again. That's why you don't have a step 2 back. Like I think they had somebody who didn't know what they were doing put it together and then say that, oh, this is where I'm struggling, and they take a note and then they fix it final assembly. Little details like that, kind of fun. So things were going great up until it came time to focus the laser. And then I had problems. I didn't know what they were talking about in the instructions. Instructions show you to place a piece of plywood down and use that little metal cylinder thing to focus the laser. The problem is mine doesn't look like that. So do I remove the little plastic shield guard thing? I don't know. So I took to the included videos they give you to try to figure it out, which is on this little USB drive. Thankfully they did, because that saved me a while of, reading through the internet forums to realize I'm just looking at it backwards. So what I think we're doing here when they say focusing the laser, I think what we're doing is just setting the height axis, the Z axis. So we put that there, loosen our thumb screws, slide laser down, it hits that, and our axis is set. All right, moment of truth. Get that plugged in, plug this in, put the SD card in there, like the video thing I just watched shows. Alright, we got a beep. Get rid of that. Get off there. So let's figure out how to cut something. Engraving. Looks like we have compass. I don't really want to do this on my Malamine, so let's hope I don't know where it's going to want to find center. So let's just find here. What do we have? Bird, ray. So we have 3 pieces of plywood, and we have 3 built-in little cutting things. Let's just go with the first one. Alright, let's go back. set our 0. Yeah, whatever, good enough. Alright, well, let's engrave and see what happens. You're not done. The layering machine. Yeah, I know positioning's done. I want to engrave. Alright. Oh, look at that. There it goes. Alright, so you need to frame it first, and then you just hit OK, and then it cuts. Not doing what I do and click engrave, and it's saying, okay, well, frame it. Alright, so that took 30 seconds to figure that out. That's fun. Sit back and let it do its thing, I suppose. How stinking neat is that? Well, dude, keep going, you know what I mean? This is kind of funny. Engraving job is done. Yes. That should say okay. I think I just need to figure out how to center it better. Because I was trying to get it centered there. It didn't really happen. But I think the compass is much neater than the longer company logo. It's good they do this though, because it gives you different examples of what it can do.
Showing me how much longer it has, so it's like 99% right now. So it's almost done.
The level of detail this thing can do is pretty impressive. Like, I'm cutting out all these little slots in this little phone stand I just made. Oh, there's a website called Thingiverse where people design and make stuff and then they upload their drawings so that you can make it too if you'd like. It's more popular with 3D printers, which maybe I'll get next just to play with. But anyway, so I downloaded this phone stand from there, and it has a lot of these little slots and stuff. So these slots you could probably cut out with, you know, a CNC router or something, or a CNC Dremel, without any real issue. But these squares, I mean, you're never cutting an inside corner like that square with any tool-based machine, because, you know, let's say you're using a 1mm end mill or an 8mm end mill or whatever, you can't cut an inside square. You can cut an outside square by, you know, having the tool pass over it and then coming back and having the tool pass over it. Outside corner, no problem. Inside corner, never gonna happen. You can get close, but you ain't gonna have it square. The laser, no problem. There. Phone stand. Now, seems silly, who needs a phone stand? It's actually for the kiddo when they want to watch my phone. You know, you balance the phone on something and they always knock it over. So I saw the little phone stand on there and I was like, you know what, I'm gonna make that. Okay, so there are some things that I am familiar with because of my CNC router that I have. But you should also know my CNC router was built using inch standard stuff, American Standard parts. So the machine is coordinated in inches. The software I use, Fusion 360, I have it set to inches. So when I post-process, everything about it is in inches. That's what I'm used to. This machine is calibrated in millimeters. Inkscape, by default, goes to millimeters, and Laser GBRL, which is the code this machine uses to cut and stuff, is also calibrated in millimeters. So I designed a gear in Fusion 360 in inches. I then exported it to Inkscape, now in millimeters, and then sent the Inkscape code to Laser GBRL to give me the G code to run the machine, again now in millimeters. And this is what I have. Again, designed in inches, cut out in millimeters. This is a 60-tooth gear for a number 40 roller chain with a 1-inch inner diameter and a 1/4-inch keyway. And that is just perfect. So shaft is fine. Now chain, which is the real question comes in. Fits perfectly. Yep, perfect fit. All right, I was looking around other what kind of mechanical stuff I have. This is a T8F, I believe it's called, or an 8mm roller chain. It's for use for those little like 50cc pocket bikes and stuff you've come across. So these are left over from the iron pipe lamp that I built. So I have the chain and I have a gear and I have a quick link. So I wanted to do something with the 8mm chain. So I whipped up a little 8mm gear. It should be noted, I was up for probably about an hour last night figuring out how to make this gear in Fusion 360 and get it over to Inkscape. Then this morning I woke up and I was like, oh, you know what? I got that little 8mm chain. I'm going to make something for that. So I made this little gear with these little standoffs and stuff. Including cutout time, I probably spent 7 minutes making this part. Like, now that I understand what's going on with it, it's incredibly easy. So it's pretty simple to learn this stuff. I have this little 12-volt gear reduction motor. It has a, I don't know, some metric shaft with some little flat spot. Again, designed using inches, so it'd be like, well, let me measure it for you. There, so it's got a 0.2360 diameter shaft. Does that make sense? And look at that fit. And the chain. This is the smallest gear profile I could make that'll work with the chain. Look at that. Perfect. So now I can use this little wooden gear to drive this little chain to make something. I'm thinking about making my kid a windmill. Like put this on the bottom and it drives the chain that drives the gear, which drives a little windmill looking fan. But that's for later. But, all right, enough playing around. Let's get to why I bought this thing. And that is gaskets. That gasket is $10. If you make a mistake or just need to do a water pump and you need to pull a power head off of a 5.5 or 6 horsepower outboard or 7.5, you're spending $10 on the gasket on top of the $75 water pump. So these get expensive, especially if you do it once and then you make a mistake and you do it again. After years of doing it, it doesn't happen too often, but occasionally it does, which will be probably 2 more videos down the line showing you what I'm fixing. So I don't want to go buy another gasket because it's $10 plus shipping. So, you know, you're looking at $17 on most places to get this gasket. It gets expensive quick. This is my old junky scanner that is warming up. Get this gasket looking as good as I can. When I first started making gaskets with the router, I told everybody that I was going to start scanning every gasket I got, and I did for the longest time. Come on, ruler. The problem was I just didn't care. My machine wasn't that good at cutting out gaskets. But now that I have this, I'm probably going to make a public file share folder where anybody can go access the gaskets in case they want to make their own gaskets or need to make their own gaskets. I may or may not have the scan for it, and I plan on having a little public folder so you can upload your own. We'll make a little gasket sharing community, if you will. So what I do when I scan the gasket is I have this little ruler, and that's going to be to calibrate the image to tell us how big or how small it is to make life easy. So I originally was only using a ruler with inches, and then I realized that's silly, and now I have one with inches and millimeters on it. So all I do, put that in the scan bed, load up a little bit, throw on a gasket, whichever way you feel like, and I scan it. At some point I'll make some long detailed video of how to actually make a gasket, but it's pretty simple with this Inkscape software. Alright,
Alright, so there is my gasket. We can stroll down here, and you don't have to trust me here, but these lines on the ruler line up with the lines up top. That's all that's really important. It looks a little weird, but hey, whatever works. Yeah, I don't know if this shiny metal base is a good idea, but since gasket materials usually come in a roll, they have that natural bend to them. So with this, at least I can put some magnets down. It's not perfect, but let's see what happens. Use the little gauge block they give you to set the height. Set it right there away from my magnets. Engrave, choose my gasket, framing. So right about there I can slide the magnet. Let's try that again. Alright, so that's not much, but let's see what happens. Now, I've never cut this material before, so I don't know if it's gonna come right out or not. Doesn't quite appear so. It feels loose. Mostly through. I think I'm gonna give it another pass. I probably made too many passes here. Not the machine's fault, really my fault. It kind of charred the edges more than I was expecting. Wipe off gasket, get some of the soot off of it. Yeah, the lighting in my garage here really does suck. So there's our gasket. That thing looks pretty darn good, I'd say. Now see the natural curve of the paper because it came on a roll. The laser cutter didn't care that much about that, it seems. Seems fine, really. Here's the gasket we scanned. And that is absolutely perfect. I would have no troubles using that. Yep, that will work fine. Also, turns out I was wrong about the price of that gasket. It is not $10 anymore. It is now $13.49. So, kind of a lot. Plus shipping, mind you. So, it took about 2 minutes to get the scanner set up to scan it. And then it probably took another 5 to 7 minutes in the scanner and probably another 3 minutes to cut it out here. So, all in all, if I didn't have to scan it, I'd probably be into this thing 10 minutes. 10 minutes to save $20 after shipping, perfectly fine with me. And now that I have the G-code, I can just pop them out whenever I want. After looking at the longer website here, I noticed it said high accuracy. They are not kidding. That thing, like when I first started cutting it out, I didn't know how many cuts I was going to need to take, so it was kind of a couple of tests I did. I just ran the G-code again and it went right back and cut right over the same spot. It is incredibly accurate. They're not wrong there. Also, 10 watt, when I was looking up information on how to use this thing or other ones for the G-code exporting, most people are running like 5 watts. So 10, that's pretty powerful. See, I'm eyeballing this thing. I'm thinking about getting this just to kind of help with the cuts, but also here, I was kind of iffy about it because I knew that gasket material comes in a roll and it's all rolled up, and I probably wanted to use a magnet. High strength steel, so our magnet will work on it. So probably getting one of those. And that was me learning how to use the laser engraver. It's a good machine. It's an accurate machine. It's pretty well built. Sell replacement parts for it, accessories. All in all, I'm happy with it. I think it'll be good to make trinkets and stuff for the kids to play with, and for my own uses. Mainly, probably gaskets. At least for me. I know the lady's got a lot of ideas of things she wants to cut out and paint and put around the house, and the kids always want something to play with, so I'm sure it'll have a lot of uses. The machine did great for everything I threw at it. Cork, I mean, it cut cork no problem, but I was a little concerned with how charred it was getting. The machine, it has an auto shut-off feature to where if it detects a flame, it turns off. It cut out that circle with no flame detected, but it still cooked it a little more than I would have liked. So I want to learn how to like lessen the power of the laser and then try to make some more cutouts. If you're in the market for a laser engraver, I'll put a link below. I'll also put a link down there to a shared folder when I figure out how to make one. And otherwise, if you've got any questions, let me know. If you want me to make a detailed video on how to make these gaskets, let me know as well. And yeah, that's really it for now.